Hello everyone. Let us begin with the discussion. This video comprises of the questions based on hybridization, bond and lone pair, geometry and shape in context to SLET examinations conducted by the Maharaja Sayaji Rao University, Baroda, that is Gujarat State Lecturership Eligibility Test. We are going to just cover these topics, and in context to our topics that have been mentioned over here, let us start solving the questions. The first question that I am displaying over here is from SLET 2019, the latest one or the last SLET that was conducted. If you look into it, they have very clearly mentioned regarding the molecular shapes they require for ClO2 minus, BrF3 and ICl2 minus. Now, for solving these type of questions, we have a very basic formula that we take into consideration. If we just quickly go through this formula, I can bet that it becomes very easy for us to solve such questions. So let us have a look at the formula. What we will be doing is, let us take this molecule ClO2 minus, the first molecule, into consideration, ClO2 minus 1. Just make a total of all the valence electron present in each of the atom. If we consider chlorine, a halogen with 7 electrons, 2 oxygen each with 6, and 1 electron in excess because of this negative charge. If we just simply make a summation of this, that is the total, we would end 7, 6 to 12, that is 19, and 1, 20. Now comes the first equation into consideration. What is that equation that we will be taking it into consideration is, if this total is less than 8, if this total is less than 8, you divide that number by 2. But if this total is greater than 8, you divide it by 8. Now the question comes, if this total is exactly equal to 8, always divide it by 2. So we have two conditions, two scenarios existing. If the total number of valence electrons in each of the atom in a molecule or a ion are equal to less than 8, we will divide it by 2, and if this number exceeds 8, we will divide it by 8. As the number is 20, let us see what we can do. As the number is 20, I will just divide it by 8, so it is 8 2 times 16, we are left with 4. Now is the number 4, which is less than 8, so the second step is the division by 2, and I will end up with 0. Friends, this formula will always help you to get your answer as double zeros in just a maximum of 2 divisions. Now let us just consider these 2 divisions, the first and the second. Always remember, there will be no change at all apart from few exceptions. The first number will always suggest you bond pair of electrons, and the second number will always suggest us the lone pair of electrons. So we have both the things available with us, that is a bond pair and a lone pair. So from the first ever formula we will get our answer that for ClO2 minus there are 2 bond pair and 2 lone pair. So if we keep this word respectively into consideration, we know what to do, and for this ClO2 minus, the same with 2 and 1 lone pair of electrons respectively. So we are supposed to find out lone pairs and whether the shape remains equal or not. So we'll have to do both the things, the shape as well as the lone pair. So coming towards the lone pair first, as I am trying to find out the lone pair, we can very well see that there are two lone pairs. So these three examples will remain as of ClO2 minus is considered. So this example is gone on its own. No need to think much of this example. Let us move a step ahead, taking into consideration BRF3. Whenever we say BRF3, what happens? You have 7 from bromine, just seven from bromine plus 7 multiplied by 3 of fluorine, so a total of 28 electrons. When you have a total of 28 electrons, applying the same formula, 28 is greater than 8, so I will divide it by 8, so I will end up with 3. So it is 24, I am left with 4, it is less than 8, so I will divide it by 2, 2 times 4, I am ending with 00. So from this particular thing, it is very clear that this denotes bond pair, this denotes lone pair. So now again our answer is 2 lone pair for BRF3. So in context to BRF3, again my answer will be 2 lone pairs. So all the 3 answers which stand again. So now it is getting a bit clumsy to differentiate our answer from only lone pairs, but nevertheless it's a learning process for us. Going with the third example, ICl2 minus 1. Whenever I say ICl2 minus 1, 7 from iodine, 2 into 7 from chlorine plus 1 excess, so it is 21 and 1 are 22. So whenever I have this number 22, I will just divide it by 8, so I will have 8 2 times 16, I am left with 6, 2 3 times 6, so 0. So over here, looking into it very clearly, I will have this idea that there are 3 lone pairs again. So 3 lone pairs, so if at all I check 3, this is the only one having this. So I need not to go now with the selection of the shape, that is whether the shapes are same or the shapes are different. Obviously, as only one answer is getting considered, the shapes have to be different, and definitely yes, you can see 2 plus 3, 2 plus 2 and 3 plus 2. So the total number of bond pairs are also differing, and therefore shapes will differ because bond pair determine the shape. Over here you have 2 bond pair, over here you have 3 bond pair, and over here you have 2 bond pair. So as the number of bond pairs are different, also the number of lone pairs are differing, definitely it is going to differ. So this is how you can target a question of inorganic chemistry, and option number D is correct. Let us move ahead with another example. You can look into it very well. Again, it is SLET 2019. The question is again related to hybridization. Friends, I have been always telling everyone and anyone that hybridization fundamentally your +2 topic along with the undergrad chemistry topic, that is molecular structure and chemical bonding, is one of the very important concept in inorganic chemistry, because questions do come from it, because it has a lot more of concepts to be learnt and to be taught. So let us move ahead. Among the following, which pair of sulfur atoms do not have sp3 hybridization? So our target is not to get sp3 hybridization, and the formula again remains the same. Always remember, friends, whenever I say that I am determining hybridization for a molecule, the summation formula will work out. Let us check the first one, that is SO4 2 minus. Whenever I say SO4 2 minus, 6 electrons from sulfur along with 6 electrons from each oxygen, I have 4 such oxygens plus excess of 2 electrons. So what will happen? 6, 6, 4, 24 and 2. So I will be ending with 32 friends. Now comes a very important rule for hybridization. As it is 32 now, see what happens. I am dividing it by 8. What was my rule? If the total is less than or equal to 8, divide it by 2. But if the total is greater than 8, divide it by 8. And you can see the total is greater than 8, so I am dividing it by 8. So it is 8 4 times 32, and my answer is coming 0 at the first step, and the number is 4. Friends, always remember, sum up the bond pairs and the lone pairs. And remember, if the total comes out to be 2, 3, 4, 5, 6 and 7, surprisingly your answers will be SP, SP2, as of now SP3. We have to find do not have SP3, but SO4 2 minus has SP3. Moving ahead, SP3D, SP3D2, and the last one SP3D3. I need to make a little correction over here. I by mistake have made it look like delta, so it is S. This is how it works. So SO4 2 minus, because of these 4 electrons, will always be considered as sp3. Let us check the second example available over here with us, and that is SCl2. Now I am going a little bit direct because I have confidence that you might have learned the technique. Sulfur has 6 valence electron, each chlorine has 7, 14. So it is 20. This newer board, newer technology is a bit new to me, so please support me, be a little patient. 20. When I will divide it by 8, I will have 2 times 16, left with 4, a number less than 8, so I will divide it by 2, 2 times 4, and the answer will be 0. So friends, you can see over here that it is 2 plus 2, again a total of 4, and when a total of 4, it is sp3. So both these examples go as sp3. So first option will not work because you are supposed to find out do not have sp3 hybridization. It has sp3 hybridization. Okay, do not have sp3 hybridization. Coming to the second one, H2S and SF2. H2S, a very important molecule, 2 atoms, 2 electrons each from 1 hydrogen, plus 6 from sulfur. It's a total 8, and when it's a total 8 divided by 2, friends, you can judge it very well. It is 4, and if it is 4, it is again sp3. Second example is important, SF2. Let's have a look at it. Sulfur has 6 electrons. Sulfur has 6 electrons plus each fluorine has 7, 14. So 14 plus 6, it is 20. You remember this 20, it is always 2 plus 2, so 4. So again, as it is 4, it has to be sp3. So this example will also not work because both the answers are sp3. Let us move ahead and check SO3 and SO4 2 minus. SO4 2 minus we already know it is sp3. Let us check for SO3. I am just going this way to solve it. SO3, 6 electrons of sulfur, 1 oxygen has 6, so there are 3, so it is 18, my friends, and you will end up with 24. Is it okay? S 6 valence electrons of sulfur and 18 valence electrons from oxygen, making a total of 24 valence electrons. And when the number of valence electrons are 24, you just make a division by 8 and you yourself will get an idea that it is 8 3 times 24, and when it is 8 3 times 24, friends, it will shift to sp2. So probably this is sp2 and sp3, so this has to be our answer. Option C, SLET 2019. But just let us check SO3 and SO2 what happens. One is sp3, one is not. One is sp3, one is not. Among the following, which pair the sulfur atoms do not have sp3 hybridization? Means both should not have sp3 hybridization. Definitely this is not sp3 hybridization, it is sp2 hybridization. Coming towards SO2, let us just check SO2. Sulfur has 6 electrons, oxygen has 6 and 6 12, so it's a total of 18 electron, friends. When the total is 18 electrons, you divide it by 8, it's 8, 2 times 16, you are left with 1, so it will be, friends, 2 plus 1, a total of 3, and it will again go with sp2. So friends, both these options, SO3 it is sp2, SO2 it is sp2, so the fully correct answer for my question has to be option D, SLET 2019. In this option, only SO3 is a molecule where sulfur atom does not have sp3. But I have been asked very clearly in the question of SLET 2019 that both, because it is not mentioned a single one, so we have to go with both, and henceforth, friends, our answer will be D. I hope you are getting it, and you might be also now getting an idea how important this simple topic hybridization is. In the link below, you can find the videos for this particular topic which already has been discussed earlier. Let us move with the next question. Which of the following on thermal decomposition yields basic as well as acidic oxide? Friends, it is no more a question of hybridization, although we are going through all the questions of hybridization also after this one, but I thought of taking a question over here in between, and that's why I am taking, otherwise need not to be. But if I look into this question very well and I keep my focus on calcium carbonate, I will get a very simple answer if we think properly. Calcium carbonate, when is thermally decomposed stands for heat, dear friends. It will always end as calcium oxide plus carbon dioxide. Question has been asked that which of the following on thermal decomposition, just by heating it, gives one basic and other acidic oxide. So this is my general compound, calcium carbonate. When I heat it, I am doing nothing other than thermally decomposing it. It will give me two answers, calcium oxide and carbon dioxide. Whether they fall in the category of basic and acidic oxide, we need to check it from our +2 knowledge, and our +2 knowledge tells us very well that metal oxide are basic in nature because the metal oxides, when combined with water molecule, they always forms hydroxides, and these hydroxides are basic in nature. So calcium oxide will be basic oxide. Talking of CO2, that is carbon dioxide, it is very well mentioned that carbon dioxide on combining with H2O results in the formation of H2CO3 carbonic acid, again an acidic product, and therefore this is a acidic oxide. So the question has a very perfect answer to be addressed from our side, that CO2 is an acidic oxide and CaO is a basic oxide. So definitely yes will be our answer to the choice. Calcium carbonate is a material which on thermal decomposition, that is simply heating, will result into a basic as well as acidic oxide. SLET 2019, a very simple question. I hope you are getting it. Let us move with another question, SLET 2018. It is very clearly written shape. So be very precise while answering. Generally it is formatted that you have shape and geometry both to be addressed. Now whenever someone asks for geometry, generally it is in the knowledge that both bond pair and lone pair are to be considered. But when we say that we are focusing only on the shape, yes, then only and only the bond pair are to be considered and not the lone pairs. If such is the case, let us check for ClO3 minus. ClO3 minus 1, chlorine has 7 electrons, each oxygen has 6, so 18, and 1 extra electron because of this negative charge, so 18 and 8, I'll end up with 26. Now comes the very important thing. The number is greater than 8 and therefore we need to divide it by 8. So when we divide it by 8, it is 8 3 times 24, we are left with 2. Dividing again by 2, it's 2, 1 times 2, 0. So if you check it very well, you have 3 bond pair and 1 lone pair. Friends, be very precise. 3 bond pair and 1 lone pair. The geometry, I am not talking of the shape, the geometry for such type of structure will generally look like this: ClO3 minus. Now what is actually happening over here? You need to think for a while regarding the Lewis structure or the Kossel-Lewis explanation. This 1 electron, 2, 3, 4, 5, 6 and 7. These 7 electrons will be the chlorine valence electrons and the rest will be oxygen, and the one will be the extra electron. So if I talk of the geometry over here, I'll always have to consider both bond pair and lone pair, and then I'll just end with a very simple concept of mind, that is tetrahedral. But if I am going to consider a shape out of it, no need to consider the lone pair, and if I do not consider the lone pair, the answer is very simple. I have only the 3 oxygen to be considered, and just considering the 3 oxygen and nothing else, it very precisely has the answer pyramidal, and opting for pyramidal will always fetch you a full score. So pyramidal is my answer. Hope you are getting it. Hope you are thinking in the right direction. And although if you have any questions, comment box is always open. Which of the following does not have a coordinate covalent bond? A very, very, very important question, because it is rightly associated with chemical bonding and molecular structure. Let us start with a simple molecule SO2, HNO3, H2SO3 and HNO2. We have the first option to be solved, and that is SO2. Whenever I say SO2, on a very simple aspect, if I try to say, we will generally represent it like this. We always represent it like this in a Kossel-Lewis format. SO2, an angular molecule, and generally we say it to be Ab12. Moving a step ahead, option B, it is HNO3, a popular molecule having a coordinate covalent bond. I know I have not spoken anything regarding the coordinate covalent bond in this particular structure, but I am coming to it. Don't worry, I am coming to it. I know it very well and I am coming to it. HNO3. Whenever we say HNO3, we have a nitrogen. This particular nitrogen has two bonds over here, one bond O and H, yet I am maintaining a suspense regarding the covalent coordinate bonds. Coming to the option number C, H2SO3, S double bond O, OH, OH, and option number 4, HNO2, that is HONO. I am just going to go a little bit different way solving this question. Is I am first going to solve option number D, that is HONO. See how. I have an oxygen over here, two lone pairs with oxygen, and apart from these two lone pairs, two single electrons which will in combination combine with hydrogen over here and nitrogen having one such electron. Now there will be two more electrons from nitrogen and another two. On the other side I will have oxygen. I will just need to remove this way. Now if you look into this structure very carefully, what I am going to explain, keep your eye over there, that is important. This particular electron pair, this particular electron pair and these particular electron pair are getting shared, and when they are getting shared, it is no more a coordinate covalent bond, it is a covalent bond. So I have an answer ready with me, that option D is the only option where you will find no coordinate covalent bond. But I need to make you understand the importance of coordinate covalent bond also, and therefore I'll insist you to go through HNO2. Whenever you are going through HNO3, sorry, not HNO2, HNO3, this particular lone pair present here, what will it do? It will get donated, and when this gets donated, the structure looks like HO, that is a covalent bond, N double bond O, a covalent bond, but this particular lone pair is now going to get completely donated towards a oxygen atom. So this particular bond is now a coordinate covalent bond. So friends, HNO3 has a coordinate covalent bond. HNO3 has a coordinate covalent bond. Similarly, these two structures, SO2 and H2SO3, also comprises of coordinate covalent bond, but in what manner? For this particular sulfur molecule, this sulfur has these two bonds present over here along with these two bonds, but if you look very carefully into this structure, then and then you will get an idea that there is a lone pair present over here, that are two electrons of sulfur, the third electron of sulfur and the fourth electron of sulfur, and therefore friends, no need to write a double bond over here. You can simply draw an arrow like this, make oxygen mark like this. I mean to say that the total number of electrons of sulfur will be 1, 2, that is a coordinate covalent bond, 3rd, 4th, 5th and 6th. Only 6 possible electrons of valence sulfur. This is how it looks. So generally we write a double bond, but it is not a double bond, friend. Remember very well, it's a coordinate covalent bond over there. SLET 2018, and this I am leaving to you. I hope you will come up with some discussion in the comment box regarding SO2. But as of now, the answer is to be considered. It's crystal clear that SLET 2018, no coordinate covalent bond, and the answer is HNO2, and that is nitrous acid. Let us move a step ahead. Let us think something else from the same concept. Yes friends, SLET 2017, and whenever we have SLET 2017, it's a question that ideal tetrahedral shape. Ideal tetrahedral shape. A very, very important sort of a question. SF4 will never have an ideal tetrahedral shape. I'll tell you why. Always remember one thing friends. Ideal tetrahedral, जिसे हम हिंदी में आदर्श कहते हैं, ideal tetrahedral is something that can be only considered when only and all bonds are bonding pair of electrons. When you do not have a single non-bonding pair of electrons, then and then only you can consider it as a ideal structure. In SF4, if you closely look at it, it is something like this. 4-fluorine, it is no more tetrahedral, it's a square planar shape and an octahedral geometry. So it is directly out of the race of being tetrahedral. How? 6 from sulfur, 7 4 times 28, so the total itself is 34. Friends, I have made a little bit of a mistake over here, but I will rectify it. 34, so it is 4 bond pair and 1 lone pair, and as it is only 1 lone pair, I will just be eliminating this lone pair. Then also my concept is right, that it's a square planar shape and a square planar pyramidal geometry, so it will not fall in this category. Coming to SO4 2-, just now we have solved it in one of the previous question, that SO4 2- is a sp3 geometry, and fundamentally speaking it looks like a tetrahedral in shape also. So let us keep a close eye on this. But remember one thing, SO4 2-, sulfur has 6 electrons, each oxygen has 6, so 24, and plus 2 excess, so total of 32, and when the total is 32 and you divide it by 8, you get a perfect 4. All bonds are bonding pair. So this might be the short what we require. S2Cl2, a very wonderful chemistry. It's a type of a H2O2 structure. It's an open book structure. Why? I'll tell you. It is many times written like this. So I do not consider it to be in a race itself, although I'll check it. 6 2 times 12 and 7 2 times 14, it's a 26. Nevertheless, it is 3 plus 1 if you consider, but I do not consider this molecule itself in the race, so it is out of the game. I am left with SO2Cl2 where S is the center point. So SO2Cl2, we need to check it. So it is 6 plus 6 2 times 12 and chlorine 14. So friends, it is 32. It is 32. Let us check once again. Sulfur is 6. 6 2 times 12 and 7 2 times 14. 14 plus 6 20, 32. And 32, so when I'll end it, it will be 8 4 times 32. And when it is 8 4 times 32, I am quite sure that I need to put it like this. Again, it's a tetrahedral. So you have two options that closely look tetrahedral, but an ideal tetrahedral. So all bond pairs, even all bond pairs. Negative charges do imply, negative charges do not imply. Let us keep as of now these both options correct, but definitely only one will be right. Discuss a bit on this in the comment box so that I'll be replying a perfect one for this SLET 2017. The molecule BRF3 is T-shaped. Justify it. The half question is written over here, but as it is a T shape, always remember bromine is in the center. You have one fluorine over here, you have second fluorine, you have third fluorine. So you can now visualize a T shape and you have two lone pairs. If you look into the structure very carefully, you will get an idea that it's a trigonal bipyramidal geometry. So if someone comes out with a question related to geometry from this, I'll always say it to be trigonal bipyramidal. If you are asking me the hybridization to this one, I will always say sp3d, but if yes, you are asking me the shape, I'll justify it to be T. So this is how it works. 3 bond pair and 2 lone pairs. I hope you are getting it. Let us move a step ahead. The 9th one. Total number of lone pair of electrons in I3 minus. Be very clear, people made mistake. Total number of lone pairs in I3 minus. People will make mistake. See how. They will just go with Deep Sir's formula, or a formula that is available by many people on the net, including me. I3 to the power minus 1. Each iodine is 7, so 7 multiplied by 3 plus 1 in excess, so it will be 22. Friends, whenever we say 22 and we start dividing it by 8, we always end up writing 8 2 times 16, left with 6, 2 3 times 6, 0, 2 bond pair, 3 lone pairs, and definitely lone pair पूछा गया है. We have been asked lone pair. I am getting 3 lone pair and I have option 3 lone pair. I got a good number in SLET. This is wrong. Total number of lone pairs. Now you see what happens. I in the center with 2 more iodine in the 2 sides, along with 1 lone pair, second lone pair, third lone pair. Now 3 lone pairs of this iodine, 3 lone pairs of this iodine, and 3 lone pairs of this iodine, a total of 9 lone pairs. and so my answer will be 9, SLET 2016. I hope you are getting the concepts clear. You are now getting a bit of a confident when you are solving such questions, and you will be opting for your exams. How many bonding and non-bonding electron pairs are there in a BF3 molecule? How many bonding and non-bonding electron pairs are there in a BF3 molecule? Let us check. BF3. If I just go through the formula, it is very easy. Boron is 3. Each fluorine has 7 electrons, so the total is 21, and my answer will be 24. What are we doing? We are just making a sum of the valence electrons of each atom, and if it is 24, you know it very well. 8 3 times 24, so all 3 bond pair, no lone pairs. So 3 bonding, but this is a query, 1 non-bonding. So how many bonding and non-bonding electron pairs are found in BF3 molecule? Let us check for the Lewis structure. 1, 2, 3 fluorine. Again another fluorine, and the third one. If you look carefully, BF3 molecule has 3 bond pairs in the center. Rest of all are lone pairs. So friends, this is where I have a bit of a doubt. I wish you to discuss on this with me. So I can find 3 bonding, but I have a dilemma of this 1 non-bonding. Hope I'll get an answer from your side. Let's hope. SLET 2016. And now the last one, SBF5R dash. A very precise one, just based on a formula, SLET 2017. Let us see what happens. In such competitive exams, there are many a times that you get bonus for a question that has been asked, because sometimes paper setter failed to go for the correct answer unknowingly. So nitrogen, phosphorus, arsenic, antimony and bismuth, general 5 valence electrons, each fluorine has 7, and I have 5 such fluorine and 1 electron in excess. So 35, 5, 40 and 1, 41. This is a dilemma. Odd number. Generally when you have an odd number, you will not go with a clear-cut hybridization. So question number 11, that is the last one, SLET 2017. This one, these two are the questions I am leaving unanswered for you. Let us get together, solve them, go through this video. If you have any queries, you can ask me. In the link you can see few of others video directly related with hybridization which are recorded by me earlier. Coming back soon with something new for SLET exams. Thank you.